The first expensive AI agent context engineering mistake I keep seeing is not missing context. It is burying the useful context under everything else. One team loaded the entire engineering handbook into a coding agent. Style guide, release notes, data rules, deployment checklist, even old migration advice. The task was a tiny logging change. The agent followed the style notes perfectly, but missed the one rule that said, "Do not log customer identifiers." Review caught it late, after test data had already been polluted. The root cause was not a weak model. The naive fix is simple. Give the agent more documents. It feels safe, because the rule is technically present. In production loops, present is not the same as operational. Long prompts create three problems. First, they cost more on every turn, including turns where the rule could never apply. Second, they dilute priority. A critical security rule sits beside a naming preference, and the agent has to infer the difference. Third, old instructions linger. When a process changes, one stale paragraph in a giant context pack can keep causing bad work. Minimum authoritative context is the goal. The smallest set of current rules that controls this task, this phase, and this risk. The pattern is skill routing. A skill is not a vague capability label. In this system, a skill is a small, versioned knowledge package that says when it applies, what must happen, what must never happen, how to verify it, and which files are authoritative. The router reads the task, matches triggers from a manifest, loads only the relevant skills, and changes the loaded context as the loop moves from planning to action to verification. My opinionated rule: if a document does not change the agent's decision or the verifier's check, do not load it. Store it, index it, link it, but do not make every agent carry it. Mechanically, I like a skills directory. Each skill gets a folder and a skill.yaml file. The core fields are ID, version, last reviewed, applies when, required rules, prohibited, verification, and authoritative files. Then, keep a manifest.json at the top level with each skill ID, its triggers, risk level, and phases where it may load. The loop starts by classifying the task and current phase. It selects candidate skills from the manifest. It loads the skill YAML plus the listed authoritative files, not the whole repository. After execution, the agent emits a receipt, skill ID, version, phase, rules used, evidence, and verifier result. If the task expands, the loop pauses and reroutes before continuing. Imagine a coding agent gets this request: add audit logs for failed payment attempts. The router sees triggers, audit log, payment, customer data. It loads a PII logging skill with risk high, plus an audit events skill with risk medium. The planning phase sees rules like never log raw account identifiers, must use the redaction helper, must include event type and correlation ID. During coding, it loads the exact helper documentation and logging examples. During verification, it loads the checks, grep for forbidden fields, run the logging unit tests, inspect sample output. The final receipt says PII logging version 1.4.2 was applied, lists the redaction helper, links the test output, and records that no prohibited fields appeared. This pattern does not make context selection magic. Bad triggers can miss a required skill, especially when the task is described in business language and the skill is named in engineering language. Receipts can also become theater if the verifier only checks that a receipt exists. Verify the evidence, not the form. Skill sprawl is another failure mode. 50 overlapping skills can be worse than one handbook. Conflicts must be handled in writing. I use a precedence order. Security beats privacy style. Legal and compliance beat product tone. Task constraints beat preferences. And local repository rules beat generic examples unless a higher risk rule says otherwise. Also, last reviewed is not decoration. Skill routing sits between retrieval and orchestration. Retrieval finds information. Routing decides what authority enters the loop. It also connects to state, because the loop should record which skills were loaded at each phase. It connects to budgets, because you can set a hard cap on context and force the router to choose. It connects to verification, because the receipt becomes a testable artifact. And it connects to stop conditions. If the loop discovers a new risk, it should not improvise with the old context. It should stop, mark late discovery, route again, and only then continue. Here is the 10-minute exercise. Pick one automation you already run, preferably one that touches customer data, money, deployments, or public content. Do not redesign the whole system. Create one skill folder. Write applies when with 3 trigger phrases. Write 3 required rules and 3 prohibited rules. Add 1 verification step that produces evidence, not a feeling. Add version and last reviewed. Then create a tiny manifest entry with risk level and phases. Finally, change your agent prompt so it must name the loaded skill and emit a receipt. Run one old task through it and see what context you can delete. 3 beats to remember. First, AI agent context engineering is not about maximum context. It is about minimum authoritative context. Second, make knowledge small and explicit. Applies when, must, never, verify, version, and last reviewed. Third, when the task changes, pause and reroute. Do not let an agent finish a new job with old instructions. Skill receipts are the closing move because they turn hidden prompt compliance into something your loop can inspect. Tomorrow we keep building the pattern language for reliable agents. New loop engineering episode daily on this channel, from foundations to fleet scale.